Hello guys, so we are here to solve linear equation and matrix operations using calculator. So here I'll be using Casio scientific calculator. So to start with, we're going to solve linear equations to unknowns. So for us to solve that, we go to the mode, and then here in the mode, you can see we have 8 options, at least 8 options, and also inequalities, ratio, and distribution. Okay, but our mode that we need for this equation is this equation. So that is mode 5 here. So we need to solve two unknowns. So we go here, number 1, since that is the format for linear equation with two unknowns. So we press 1, and then there will be an augmented matrix for linear equations with two unknowns. We just simply get the coefficients, we substitute, or we input that into our augmented matrix. So that is 3, -4, 10. That is on the first row. On the second row, -5, 8, and -17. Then equals. Here we get the value for x1, which is x3, and for x2, which is y, in this calculator, -1/4. So that is our solution. Okay, next is, let's try computing for linear equations with 3 unknowns. So we go back to mode and then equation, and then 3 variables or 3 unknowns. So that is number 2. So we input the coefficients one by one. So the first row, and then on the second row, and then on the third row. Then we press equals to get the solution. Yeah, so our calculator says it has no solution. So it means that the lines did not intersect on any given point. So these lines, because these are equations of lines, so most likely they were not able to intersect at a single point. Next is this. Let's solve this. So AC clear, all clear, and input those values. Okay, so the solution is infinite solution. So most likely, um, all of their points coincide with one another. So, or they all intersected, all their points intersected. So infinite solutions. Then another one. Let's try this. All clear. So -2, 1, -1, 4. 1, 2, 3, and 13. Then 3, then 0, 1, -1. Press equals. Okay, so the value of x1 is -1. The value of x2 is 4. The value of x3 is equals to 2. So this equation has a unique solution. Okay, next up is let's try using the matrix operation. So for the matrix operation, so press AC mode, and we go to matrix number 6. And then we define each. So this calculator can handle at most 3 matrices. So for matrix A, press 1, and then this one is 1, 2, 3. So the dimension is 3 by 2. Okay, so 3. So we have 3 rows and 2 columns. Okay, so 3 rows and 2 columns. So that is 3 by 2. Then we enter the values. Right, so then, okay, press AC. Next, let's define matrix B. So for matrix B, it's also 3 by 2. 8, 1, -7, 0, 4, -1. Press AC, and then for matrix C, so let's define that also. Dimension, then matrix C. That's also 3 by 2. 2, 3, -2, 5, 10, -6. Okay, so let's proceed with the matrix operation, arithmetic operation. So that is 3 matrix A. So we press matrix A plus 2. And we press matrix B minus. So that is 1/2 or 0.5. 0.5 times matrix C. Okay, so we'll get this answer of a matrix, so which is also 3 by 2. Consisting of, on the first row, so 15 and 27.5. On the second row, -7 and -11.5. And on the third row, 0 and 4. Okay, so that's it for matrix operation. Next is, how about the dot product? So for the dot product, so this is not the same as the matrix multiplication. So for the dot product, so we go to the vector, and then we define vector A and vector B. So for vector A, so 1, so that is, it's either 1 by 3 or 2 by 2. So it's 1 by 3. So we have 4, -10, then 3. That's for matrix A. Next, for matrix B, dimension vector B 1, -4, 3, and 8. Okay, so we have here the dot product number 7. So that is vector A dot, so 7, vector B. Okay, so that's our answer. So negative 22. So there is a single answer, single value answer for to that product. Unlike in the matrix multiplication, we're only using about we're only using, let's say, an answer of matrix as well. Okay, next is we proceed with the matrix multiplication, or we call this as cross product. So first, we define the matrices. So we go to matrix. Okay, let's say matrix A is B and matrix B is D. In this case, matrix A. So it's a 3 by 3. We input the values. That is for matrix A. Next is for matrix D. In this case, we set that for matrix B. So it's also 3 by 3. Okay, so we multiply cross product VD and DB. So matrix A cross B. So we have this matrix answer. So it's possible. Next, we try reverse matrix B times matrix A. Okay, so that is also okay. So sometimes there are what we call dimension error. So which is the number of raw. Okay, the number of raw of the second matrix should be the same as the number of columns of the first matrix. So in this case, this is 3 by 3, 3 by 3. So the number of columns for B is 3 and the number of columns for D is 3. So that's equal. And then the number of rows for column B, for matrix B. Okay, and the number of columns for matrix D will define the new dimension. So in this case, they're the same, 3. We have 3 columns for D and 3 rows for B. So that's also 3 by 3. Okay, for example, let's define it differently. So for matrix B, let's make it as 3 by 2. Let's just copy the first 2 columns. And then we multiply. The one is 3 by 3, and the other one is 3 by 2. Okay, so is it possible? So yes, it's also possible to do that. Since the number of rows of B is 3, and the number of the number of columns of B is 3, and the number of rows of D is also 3. So they're equal. And the new dimension will be, since we have 3 rows for B and 2 columns for D, will become 3 by 2. If we do it the other way around, so matrix B to matrix A, there will be dimension errors since this is 3 by 2 and this is 3 by 3. So the number of columns of D is not equals to the number of row for B. So that is 2 not equals to 3. There will be dimension error. So there are cases like that. Next is transpose. So transpose is basically, it's about rearranging the rows and columns of the matrix. So anyways, since our calculator is not capable of doing the 4 columns or 4 rows, so we can only solve for these 2, B and C. Okay, 4. So let's say let's define first matrix B. So that's 3 by 3. 3, 2, -6, -9, 1, -7, 5, 0, and 12. Then define C, which is 3 by 1. So 9, -1, and 8. Okay, so what will happen if we get the transpose of this? So this is the TRN transpose. Then we get transpose of matrix B. Yeah, so if we observe, they contain the same number 3, 2, and -6 on the first column, which is originally at the first row. Next is -9, 1, and -7. Now on the second column, but before it was in the second row. So there is just interchange of the arrangement of columns and rows. Third column, 5, 0, 12. So third row, 5, 0, 12 originally. So same thing here on A, but you can only do it manually since our calculator is limited to up to 3 rows and 3 columns. Okay, so for matrix C, so we get the transpose of that. Okay, so this is vertical originally, and then it becomes horizontal. 9, -1, and 8. So for the trace, so how do you get the trace? The property of trace is simply you just you add the value on this diagonal. So in that case, that is 3 plus 1 plus 12. So that is equals to 16. So it's only applicable on symmetrical matrices. So on A and C, so trace is not applicable. Now I evaluate each of the following for the given matrix. So this is a 2 by 2 matrix. -7, 3, 5, and 1. So we can use exponent as well in matrices. So that is a squared. And then this will be the result: 64, -18, -30, 16. So we can also have it as raised to 3. So it becomes like that. Divided by 38 by 74, 290, and -74. Okay, next is inverse of matrices. So this is a 2 by 2 as well. So let's just define the data. Negative 4, negative 2, 5, and 5. So to get the matrices, the inverse of matrix. So matrix A is to -1. So that is our inverse. There is a value of inverse. So usually this is available for symmetric or square matrix, but not all time. Not all time. It's applicable. Next, let's try this matrix C. This is 3 by 3. Put the values: 310, -1, 2 and 2, 5, 0, -1. Okay, then get the inverse. So here are the values of the inverse. Okay, so all right, so that's it for now. The application of matrices using calculator. Thank you so much for listening.